Welcome to part 2 of metal joining techniques. In this session, we'll discuss resistance welding, the roles of flux and electrodes in welding, as well as brazing and soldering as alternative metal joining methods. Metal joining is the process of permanently bonding two or more metal parts, often using heat, pressure, or a combination of both. Common methods include welding, brazing, and soldering, each suited to different applications. Welding, in particular, is a widely used technique due to its strength and permanence, making it essential in industries such as construction, automotive, and manufacturing. ERW works on a few main principles. Electric current. High current is passed through metal parts, generating heat due to resistance. Pressure application. Pressure is applied to fuse the heated metal parts. No filler metal. Unlike other welding methods, ERW doesn't require filler material as the metal itself melts and joins, simplifying the process and making it economical. Spot welding is one of the most common types of ERW. Here's how it works. Process. Electrodes apply pressure and pass a current through a specific spot, melting and joining the metal at that location. Applications. Widely used in automobile body parts and appliances. Advantages. It's fast, efficient, and ideal for thin metal joints without causing significant distortion. Seam welding is similar to spot welding but uses wheel-shaped electrodes that move continuously along the seam. Applications. This technique is used for creating airtight and leak-proof joints in fuel tanks, pipelines, and tin cans. Advantages. Seam welding provides a continuous, overlapping weld ideal for joints that need to be sealed from air or liquid. But welding involves aligning two metal pieces end-to-end and applying current and pressure. Applications. Common in welding bars, wires, and tubes. Advantages. But welding produces a uniform joint without weak points, maintaining the cross-sectional area across the connection. Percussion welding uses an electric arc to preheat the metal surfaces, followed by quick pressure to join them. Applications. Suitable for welding dissimilar or heat-sensitive metals. Advantages. It's efficient and creates strong joints for materials that might be difficult to weld with traditional methods. Flux is a material applied to the welding area to prevent oxidation and contamination. It serves several key roles. Protection. Flux melts during welding and forms a protective layer, shielding the weld from the atmosphere. Stabilizing the arc. It helps maintain a stable arc in arc welding. Removing impurities. By forming a slag layer, flux assists in reducing impurities in the weld joint. Electrodes are essential in welding, acting as both the conductor for the arc and, in some cases, the filler material. Types. Consumable electrodes. Melt and become part of the weld joint, commonly used in arc welding. Non-consumable electrodes. Do not melt and are mainly used to provide the arc, with filler rods added separately if needed. Selection. The choice of electrode depends on factors like material type, joint style, and welding position. Different types of weld joints are suited to various applications. Butt joint. Two pieces are joined end-to-end, one of the simplest and most common joint types. Lap joint. Overlapping pieces are joined along the overlap, ideal for thin sheets. T-joint. Forms a T-shape by joining two pieces at 90 degrees, often used in structural welding. Corner joint. Joins two pieces at a corner, frequently seen in box or frame construction. Edge joint. Used when two pieces are placed side by side and joined along their edges, suitable for sheet metal fabrication. Proper edge preparation ensures strong, reliable welds, especially for thicker materials. Beveling. shapes the edges to create a groove for better weld penetration. Cleaning removes oil, rust, and dirt, preventing contamination and ensuring a clean, strong bond. Brazing and soldering are metal joining techniques that use lower temperatures compared to welding and rely on filler materials to bond metals without melting the base metal. Brazing uses a filler that melts above 450 degrees Celsius and flows into the joint by capillary action, creating strong, leak-proof joints. Commonly used in plumbing and HVAC. Soldering operates at lower temperatures, below 450 degrees Celsius, and is widely used for electronics and small repairs due to its minimal impact on the base metals. Here's a comparison of welding, brazing, and soldering. Temperature. Welding operates at the highest temperature, brazing at a moderate level, and soldering at the lowest. Joint strength. Welding creates the strongest joints, while soldering results in weaker connections suitable for low-stress applications. Material compatibility. Welding is mainly used for similar metals, while brazing and soldering are versatile for joining dissimilar materials. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on other exciting topics.